Hi everyone, happy Monday. This is a video lesson over solving quadratics by the quadratic formula. This is your last piece of new information before your semester exam. So you're going to be working on this as well as the two other methods of solving. So solving by factoring and solving by square root method. So these three methods are going to be on a quiz that you're going to have on Thursday when I get back. And then after that, we're going to start preparing for your midterm, okay? So this should be in your notes packet. This is Unit 5, Lesson 5. I'm sure that you've seen the quadratic formula before in Algebra 1. We're not going to make you memorize it. You just have to know where to put what numbers and how to simplify things. So this is just another way of solving quadratics. So I'm going to zoom in here on this box. So first thing, you need to identify your A, B, and C value. Remember that they're located in front of the variables. So your A value here is 3. Oops. Your B value is 5, and your C value is -12. So you have the equation here. You're just going to substitute your A, B, and C. So you don't have to write this. I'm just going to do this to help us remember where I'm going to plug one in. So the B is 5. So everywhere I see a B, I'm going to put a 5. My A is 3. And then my C is -12. Okay, so we are going to simplify that down. So I'm just going to rewrite what I have here, and I'm just going to continue to simplify it as much as I can. So 5 squared is going to give us 25, and then if I multiply 4, 3, and -12, I get 144, or -144, and we've got two negatives there, so it's going to turn positive, and all that's divided by 6. Next step, I'm going to take what's underneath of my radical, and I'm going to simplify that. Okay, the square root of 169 is 13. So we're going to kind of break this off into two little equations. So you're going to have -5 plus or minus the square root of 169 is 13 over 6. So I'm going to break this into two separate equations. So one of them is going to be -5 plus 13 over 6. And the other one is going to be -5 minus 13 over 6. So you're going to get two different answers here. So I get 8 over 6. You can take a 2 out of both of those, leaving you with 4 over 3 is one of your answers. And then on the other one, you get -18 over 6. And that one divides evenly as a -3. So I got two different answers. Okay, then we have three different things down here. We're going to investigate what's called the discriminant first instead of doing, if you want to do all the work at the beginning like I did, that's fine. I'm just going to show you a different way that you can split it up as well. So looking at this example here, my A value is 2, my B value is 5, and my C value is -8. The discriminant is B squared minus 4AC. So I'm going to find that first, and then I'm going to use that and put it into my formula. It just makes simplifying things a little bit easier. So my B value is 5, so I've got 5 squared. Notice whenever I'm substituting, I'm using parentheses. My A value is 2, and my C value is -8. So you've got 25 plus 64. The reason that there's an addition sign there is because I have a -4 multiplied with a -8 gives me a positive. So if I add these together, I get 89. So now I'm just going to rewrite my whole formula just to show you how this is going to work out. Okay, what was under that radical, the b squared minus 4ac, that is now just 89. I've already found that number. So I'm going to rewrite this. My b value is 5. So in the front of the formula is negative b. You can think about it as the opposite of b. Usually this is the biggest mistake. People forget that negative sign. Just think the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So opposite of b. So if my b here is a positive 5 originally, it's going to turn into a negative 5 in my equation. Then I'm going to have square root of 89. That 89 is my discriminant over 2, and my a is 2. So I'm going to keep simplifying this. The square root of 89, you can't do anything to simplify that any further. So I'm just going to leave it as the square root of 89. And then I'm going to put that all over 4. So if I were to write this out as two separate answers, I'd have negative 5 plus the square root of 89, all divided by 4. And then I'd have negative 5 minus the square root of 89, all divided by 4. And those would be my two answers. Okay, next one, my a value is 2, my b value is 8, and my c value is 8. So again, I'm going to find my discriminant first. So I'm looking for b squared minus 4ac. My b value is 8, a value is 2, c value is 8. So I've got 64 minus 64, and that gives me 0. So I'm going to write out my original equation. So opposite of b plus or minus the square root b squared minus 4ac all over 2a, and I'm going to substitute. So opposite of b, if b is positive 8 in my formula, it's negative 8, plus or minus. Remember that this number is now going under the radical. So this is root 0 over 2 times a, which is 2. So the square root of 0 is just 0. So I really don't care at all about this portion over here. I'm going to leave it as negative 8, which is on the top, over the 2 times 2 on the bottom, which is 4. And if I reduce that down, I end up getting one single answer of x equals negative 2. Okay, let's look at the last one. My a value is 3, my b value is negative 8, my c value is 10. Let's find the discriminant. So b squared minus 4ac. My b value is negative 8. If you're typing this into your calculator, it's very important that you use the parentheses. If you do not use the parentheses and you try to do negative 8 squared, you're going to end up getting the wrong answer. So please use your parentheses. So negative 8 squared is a positive 64 minus 120 gives me a negative 56. So I'm going to rewrite my formula. And I'm going to replace my negative 56 down here on my discriminant and replace my b and a. So opposite of b, I'm going to end up having a positive 8 in the front. Square root of negative 56 all over 2 times a, and a is 3. Okay, so I can simplify this more. So I get positive 8 plus or minus the square root of negative 56. 2 times 3 on the bottom gives me 6. So immediately something should grab your attention, and it's that negative 56 that's there. In The next unit, you're going to learn about what are called imaginary numbers. If you see a negative sign under a square root symbol, we're going to call that no real solution. There is a solution, but it's imaginary and you haven't learned what that is yet. So if your discriminant is a negative number, like here we have negative 56, that means that you have no real solution. So I'm going to kind of categorize these. In this case, the case of the first question, your discriminant was positive 89. So if your discriminant is bigger than 0, meaning it's a positive number, you have 2 real solutions. And since the square root of 89 is not like a perfect square, I can't reduce it down to a single whole number, we're going to call that irrational. So if your discriminant is positive and it's not a perfect square, meaning I end up with this square root of some weird number, that is causing me to have 2 real solutions, and they are irrational because of the inability for me to simplify that square root. In the second case, we ended up getting 1 solution. So I'm going to say 1 real solution. Negative 2 is a real number. 1 real solution, and it is rational. So there's no square root symbol that I can't reduce anywhere. And then the third situation that we talked about, you have no real solution because you have that negative sign underneath of a square root symbol. Okay, moving on to the next page. We're going to continue talking about the discriminant, and we're going to graphically look at the type and the number of the solutions based off of the discriminant. So here for the first one, I'm just going to classify the different values. My A value is 1. Remember, it's not written, but it's still there. My B value is negative 4, and my C value is negative 3. If you look at the picture of the graph over here, you have 1, 2 different x-intercepts. Okay, so where it says the b squared minus 4ac is bigger than 0, that's happening because if I find the discriminant, my b value is negative 4, a is 1, c is negative 3. So we get a positive 16 plus 12. So that number is going to give us a positive number overall, 28. So my discriminant is bigger than 0. So when that happens, I have 2 zeros. Remember that zeros are the same thing as roots, are the same thing as x-intercepts, and I have 2 real solutions. So I have 2 zeros, and both of those solutions are real. You can also say solutions here. Okay, moving on to the next one. My A value is 1, my B value is 2, my C value is 1. If you want to find your discriminant, we get 4 minus 4, which is equal to 0. And looking over at our graph, looking for x-intercepts, I've got 1 right here where the graph touches the x-axis. So we know that our discriminant is 0. So how many zeros do we have? Well, looking at our graph, I have 1 of them, and that 1 that I have is a real solution. So whenever your discriminant is 0, you get 1, 0. Remember, that's the same thing as x-intercept, solutions, roots, and our solution that we get is real. Okay, the last one, my A value is 1, B is negative 2, and C is 2. So I get positive 4 minus 8. So this is going to give me a -4 overall. So my discriminant is negative. If you look at your graph here, notice that there is nowhere where the graph touches the x-axis. So I'm looking for the graph to touch the x-axis, but it never does that, which means that over here where it says zeros, I don't have any of them. Where it says real solutions, I'm going to put 0 because I don't have any real solutions. With imaginary solutions, however, I do have imaginary solutions. So something that you're going to learn about is that they always come in pairs. So this is going to have 2 imaginary solutions. So don't worry so much about what is an imaginary solution. We're going to look at that later. Just know that if your discriminant is negative, so in this case the number I got was the -4, that means that I have 2 imaginary solutions because imaginary solutions always come in pairs. Okay, there's a little rule at the bottom if the discriminant is a perfect square. So things that are perfect squares are 4, 16, 25, 36, meaning that I can take the square root of that number and it gives me a whole number. Like the square root of 16 is 4. The square root of 25 is 5. All of those numbers give me a single whole number answer. If that does happen, then the solution is rational. So like I said, if you have a case where it's not a perfect square, then it's irrational. So if you had something like on the other question where we had the square root of 89, that is irrational because I can't take the square root of 89. It's not going to give me a whole number. Okay. So this lesson just revolves around you being able to use the quadratic formula and being able to identify the discriminant, how many types of zeros you're going to have. Are they going to be real or are they going to be imaginary? So for the rest of the day today and then tomorrow, you're going to be working on a quadratic formula assignment where your only method of solving is using the quadratic formula. Let me think, what's today? Today's gonna be Monday. So Monday you're doing this, Tuesday you're doing this, and then on Wednesday you're gonna be doing like a mixed practice assignment that's gonna cover solving by quadratic formula, solving by square root, and solving by factoring. You're going to take a quiz when I get back on Thursday over those 3 methods of solving. And then that is your last assessment before you take your semester exam. Okay, so let's knock this out. I will be back on Thursday. And please email me if you have any questions or concerns. I tried to go get papers to grade on Sunday, but the building was locked and my ID wouldn't let me in, so I'm sorry. But I will try to get your grades updated as soon as I get back on Thursday.